What if the first real sign of alien life didn't come from Mars or Europa, but from a planet 120 light-years away? One wrapped in clouds, hidden beneath a sea of blue gas. A world so strange, yet so familiar, that scientists are asking, are we already staring at another Earth? This is the story of K2-18b, and the discovery that could change everything we know about life in the universe. Imagine drifting through the vast silence of space. Beyond the familiar glow of our sun, past the frozen giants and the edge of our solar system, lies a region where stars burn dim and red. Ancient suns, smaller, colder, quieter. Around one of those faint embers, in the constellation of Leo, circles a mysterious world, K2-18b. To the eye, it would seem like nothing more than a shadowed marble of mist and light. A planet roughly 2.6 times wider than Earth, nearly 8 times heavier, wrapped in thick clouds of hydrogen. At first glance, it looked ordinary, one of thousands of alien worlds catalogued by our telescopes. Just another number on an astronomer's list. But sometimes, the universe hides its wonders behind the ordinary. Astronomers began to notice something peculiar. K2-18b didn't scorch in the fires of its red star, nor freeze in the darkness beyond it. Instead, it danced in a delicate balance, the region scientists call the habitable zone. Not too hot, not too cold, just the right distance where liquid water could exist. And that single detail changed everything. Because wherever water flows, on Earth, life follows. The question was simple. Could it be the same out there? As the data streamed back, K2-18b's atmosphere began to whisper secrets across light years. Secrets carried in photons, in the faintest threads of starlight that brushed past its clouds before reaching us. Then, in 2019, the Hubble Space Telescope caught something extraordinary in those whispers. A subtle fingerprint etched into the light. Water vapor. The first time in history we had seen such a sign on a planet orbiting a red dwarf star. Think about that. A world bathed in the glow of a sun so dim you could stare straight at it, yet somewhere above that planet's clouds, water vapor drifted through an alien sky. Water, the simplest molecule of life, the foundation of everything we are. It was the first breath of possibility, a cosmic heartbeat pulsing from 120 light-years away. But even then, scientists knew this was just the surface of a much deeper mystery, because the truth of K2-18b was still hidden, locked within the faintest traces of light, invisible to human eyes, waiting for a new kind of vision to reveal what was really happening there. The world of K2-18b waited in silence for billions of years, until the right pair of eyes finally opened. Eyes made of gold and precision, the James Webb Space Telescope. Floating 1,000,000 miles from Earth, beyond the moon's orbit, Webb stares into the cosmic dark, gathering ancient light with mirrors polished to atomic perfection. Where Hubble saw the visible universe, Webb peers deeper, into the infrared, where heat and hidden chemistry reveal the fingerprints of alien worlds. When those golden mirrors turned toward K2-18b, it wasn't to take a picture, but to listen. To the faint hum of molecules whispering through starlight. Every time the planet crossed its small red sun, a sliver of that starlight passed through its atmosphere, light stretched, bent, and tinted by the gases floating above its clouds. To our eyes, that light would look ordinary, a flicker of brightness, nothing more. But hidden within it is a code, a spectrum of color and shadow that tells a chemical story. Methane absorbs one wavelength. Carbon dioxide steals another. Water, ammonia, oxygen, each leaves its own unique signature. Webb, with its unmatched sensitivity, gathered that starlight photon by photon, reading it like a scientist reads DNA, searching for patterns that shouldn't exist. Then, one by one, the results began to emerge. Methane, carbon dioxide, strong, unmistakable signals. But there was something missing. Almost none of the gas that should be there. Ammonia. That imbalance didn't fit with any known model of a lifeless world. Some process was changing the planet's chemistry.
Missing.
And the deeper scientists looked, the stranger it became. Could it be a sign of geological activity? A vast ocean breathing beneath the clouds? Or could it be something alive, shaping its atmosphere the way life shapes ours? For the first time, science and imagination stood side by side, staring at the same set of numbers and daring to ask, what if this is the first whisper of alien life?
Was altering the planet's chemistry.
When scientists examined Webb's data, a pattern began to emerge. Subtle, fragile, but impossible to ignore. The chemical fingerprint of K2-18b didn't look like the barren worlds we'd seen before. It looked familiar. The balance of methane and carbon dioxide, with almost no ammonia, mirrored something we'd only seen in one place: Earth. On our own planet, that specific ratio doesn't come from volcanoes or chemistry alone. It comes from life, from countless living things breathing, decaying, renewing the air in an endless cycle. For scientists, it was like hearing a familiar melody played on a distant instrument. And then, just when it seemed the mystery couldn't deepen further, another signal appeared. Faint, barely detectable, almost like a whisper carried across the void. A compound called dimethyl sulfide, DMS. On Earth, this molecule is produced almost entirely by life in the oceans, microscopic plankton releasing it into the air as they bloom beneath the waves. It is, quite literally, the scent of the sea, the chemical breath of life itself. If that same compound truly exists in K2-18b's atmosphere, then we might be looking at the first hint, however faint, of alien biology. But the scientists knew better than to rush. Webb's readings are exquisitely sensitive, and even the smallest calibration error can mimic the signature of life. Still, the numbers held. The pattern repeated, and the whispering whispers grew louder. Could an alien ocean be breathing beneath those clouds? Could microbial life be rising and falling with the planet's invisible tides? Or is nature, once again, playing tricks on us, crafting the illusion of life where there is none? Each new data point deepened the paradox. The more we learned, the less we understood. And in that growing silence between fact and possibility, humanity found itself holding its breath. For the first time, the question wasn't whether life could exist somewhere out there, but whether, in this quiet corner of the cosmos, we had already found it.
The data isn't proof of life.
Now, before we leap to conclusions, scientists remind us of a simple truth. Extraordinary claims require extraordinary evidence. The possible signal of dimethyl sulfide, or DMS, is real but fragile. It lies at the very edge of Webb's detection range, a faint ripple in the cosmic noise. One recalibration, one new observation, and it could disappear entirely. So no, we haven't found life. Not yet. But what we have found is a planet that defies easy explanation. A world that belongs to a newly imagined class of planets, ones scientists now call Hycean worlds. Hycean, a word born from hydrogen and ocean. These are planets wrapped in thick, hydrogen-rich atmospheres, yet blanketed with deep, global oceans. Worlds neither like rocky Earth nor icy Neptune, but something in between. Mysterious hybrids where the rules of habitability are rewritten. K2-18b is one of the first clear examples. It's about twice Earth's radius. Big enough to hold on to a dense atmosphere, but small enough that beneath that gaseous shell, something solid, or liquid, could exist. On such a world, sunlight filters through a hazy sky. warming an ocean that could stretch endlessly across its surface. Picture it, a sea tinted jade by alien chemistry, clouds of vapor drifting slowly under the glow of a crimson dwarf star. No continents, no storms as we know them, just a vast, breathing planet. Its tides pulled not by a familiar moon, but by the gravity of its tiny sun. If microbial life evolved there, drifting near the surface where light still reaches, it might feed on minerals, on sunlight, or on chemistry unlike anything on Earth. And in doing so, those microscopic organisms could release gases, methane, carbon dioxide, and perhaps DMS, into the air above. Gases that over millennia build a signature so distinctive that even from 120 light-years away, our telescopes can sense it. The invisible breath of an unseen ocean. Each molecule carried across the darkness becomes a message, a quiet announcement that something is happening out there, something chemical, something alive, or nearly so. In those whispers of gas and light, we hear the universe hinting that Earth might not be alone in its capacity for life. But not everyone is ready to call this a sign of life. In labs and observatories across the world, skepticism buzzes as loud as excitement. For every scientist who dares to hope, another stands ready to question. Some argue that the supposed DMS signal might be nothing more than an illusion, a trick of data, an echo of instrumental noise mistaken for something profound. After all, reading a planet's atmosphere from 120 light-years away is like trying to hear a single heartbeat through a hurricane. One misplaced calibration, one photon misread, and the entire illusion collapses. Others point to the physics of K2-18b itself. Its thick hydrogen atmosphere could create surface pressures thousands of times greater than what we feel on Earth. Temperatures might soar high enough to crush or vaporize anything resembling life as we know it. Even if an ocean exists, it might not be gentle and blue, but boiling, churning, heavy with exotic chemistry that would tear our biology apart. Could anything truly survive there? The question hangs over every analysis, every simulation, every heated debate. Some researchers counter that life, if it exists, doesn't have to follow our rules. Maybe evolution on a Hycean world would favor methane-based cells, or organisms that thrive in crushing pressure, drawing energy from chemical gradients instead of sunlight. To them, impossibility is just another word for not yet understood. And so, the scientific community finds itself divided, not by hostility, but by the tension between hope and caution. That tension is the heartbeat of discovery. Every great leap in science, from the first telescope to the first genome, has stood on that razor's edge between wonder and doubt. Because that's where truth lives, between the dream of life and the silence of space, between the optimism that we might not be alone and the humility to admit we might still be guessing in the dark. And so, scientists keep watching, keep questioning, keep listening for that next faint signal, the one that could finally turn speculation into certainty.
For centuries, we've looked to the stars.
For as long as we've existed, humanity has gazed upward and asked one haunting question: are we alone? From ancient astrologers charting constellations on clay tablets to modern scientists decoding light from distant suns, the question has never changed. But maybe, just maybe, the answers are finally beginning to stir.
Are we alone?
K2-18b doesn't give us proof, not yet, but it whispers that the chemistry of life, the breath of carbon and hydrogen and oxygen, may not be confined to our fragile blue world. It could be written into the very fabric of the cosmos, a recipe repeated across galaxies, waiting only for the right conditions to awaken. Every hydrogen atom, every molecule of water might carry within it the potential for life, not as an accident, but as an outcome written in the laws of nature. Think about that. It means that life, in some form, could be as natural to the universe as the birth of stars or the orbit of planets. Maybe we are not an exception, but an example. And if oceans and skies can meet on worlds like K2-18b, then perhaps, somewhere out there, the same story is unfolding under a dim red sun, different eyes watching their own sky, wondering if they are alone. In that reflection, the cosmos becomes a mirror, showing us not only the possibility of alien life, but the preciousness of our own. Because the more we search outward, the more we realize how fragile, how miraculous our own living planet truly is. If life can emerge in the depths of an alien ocean, then it can also vanish anywhere if we forget its value. So K2-18b isn't just a scientific discovery. It's a reminder that we are part of something far greater, a vast and living universe still learning how to speak its own name. And maybe, just maybe, the next time we point our telescopes toward the stars, we'll finally hear it whisper back. Maybe one day the James Webb Space Telescope will see it. A molecule, a pattern, a rhythm that cannot be denied. Not just chemistry, but biology. The unmistakable fingerprint of something alive, breathing, changing, evolving beneath an alien sky. And when that day comes, it will change everything. Not just our science, but our sense of self. Because the moment we find life beyond Earth, we'll no longer be the center of the story. We'll be part of something far grander, a living, breathing universe where creation itself is not rare, but inevitable. Maybe future telescopes, far more powerful than Webb, will capture the soft reflection of sunlight glinting off alien oceans, or the silhouette of clouds drifting across a horizon that has never known human eyes. Maybe one day, we'll watch the weather on another world and realize that life, in all its infinite forms, is simply what the universe does. But until that day arrives, every faint spectrum, every photon, every signal whispered across the void brings us a little closer. Closer to understanding what it really means to be alive. Closer to realizing that life's reach may stretch farther than our imagination has ever dared. So, the next time you look up at the night sky, remember this. Somewhere in the constellation of Leo, orbiting a quiet red dwarf, there's a small blue-green world. And in its thin shroud of gases, the chemistry of life might already be at work. A whisper across space, waiting for us to listen carefully enough to hear it. The stars are not silent. They are speaking through light, through time, through worlds like K2-18b, and through our own curiosity which refuses to fade. Because to wonder is to be human. This is Cosmic Vault, where we open the universe one mystery at a time. What if the next signal we detect isn't just chemistry, but a hello?